Hi, I'm Steven, developer advocate for Event Store. In the last video, you have learned about using reactions in event sourcing. In this final video on how event sourcing works, you will find out how everything fits together. So without further ado, let's take a look. Over the last few videos, you have learned how an event-sourced application reads and writes data. It starts at the top left, where a user initiates an action. This creates a command that is sent to the decider, which reads from the event store and constructs the current state of the system. Based on this, if the command satisfies all business rules, then an event is emitted as a result. The event is appended to the event store, which keeps all the event in the application and is often used as a source of truth. To read data, a user initiates a query, which requests a projection to build a response for it. The projection replaces a group of events from the event store and constructs a read model for its user. You can also choose to develop a projection service that is separate from the application, which listens to an event and builds a read model in some database. This can be projected to any kind of database and schema optimized for a particular use case. Finally, there are reactions, which are components that trigger an action when another one has completed. This is typically a separate reaction service that listens to events from the event store and triggers some kind of write to a system. This is useful for decoupling and scaling an action from the application layer and for coordinating between different services and applications. And this is how an event source application works in a nutshell. A helpful way to understand and remember these components is by dividing them into 4 quadrants, each with a unique property. The top 2 quadrants are related to writing or triggering actions. Both of the command and decider assist in writing to the event store, while the reaction triggers a write to an external system. The bottom 2 quadrants are related to reading. The query and projection help users retrieve data by transforming events from the event store into read models. Additionally, the projection and read models can cache optimized models to enhance performance. The major difference between the read and write sides is that write operations result in side effects or changes in the system, whereas read operations do not. For example, a decision writes an event to the event store, representing a change to the system. A reaction triggers an update to an external system. However, projections and read model do not logically change the business state. They merely provide a snapshot view of the system. Moving on, the left 2 quadrants are related to updates that are immediately consistent. These types of activities are mostly transactional and it's synchronous. This means any write here becomes immediately visible to all subsequent reads. Think of this like 2 people having a face-to-face conversation, where both are talking and listening to each other, registering each other's responses immediately. These highly responsive conversations with immediate feedback are great for in-depth discussions that help everyone get aligned and stay consistent. On the other hand, the right 2 quadrants relate to eventually consistent activities. These activities are asynchronous in nature, triggered by write operations on the immediate side, and are completed eventually, usually after a short delay. Write operations here involve updating a system, triggered by an event, which, as you may recall, represents a write operation from the immediate side. For read operations, this involves projecting to a read model in a read data store, also triggered by an event. Think of this as 2 people having an asynchronous conversation over instant messaging. One may send a message to the other, but it might not be read or responded until a few minutes later. Even though an immediate response is not received, this method of communication is more lightweight and flexible, if a slight delay is acceptable, It does not require setting up or scheduling a time with the other person, and is easier to scale to a higher number of participants. Imagine trying to have a face-to-face conversation with 100 people where everyone is attempting to talk simultaneously. This would be not much of an issue over instant messaging. Each of these four quadrants has its own responsibilities. Even though common patterns are presented in this video, there are many different variations of it. Each variation and pattern has its own trade-off and is effective in its own use case. As long as they fulfill the principles behind each quadrant, don't worry too much about whether you are using the correct pattern or variation. In the beginning, understanding the principles and trade-offs is more important. After discussing these four quadrants, let's talk about the event store, the central component that communicates with all of them. At the heart of event sourcing lies the event store, an application database that persists every event created from the application's actions and decisions. An event store contains a set of append-only sequence logs to store events and provide efficient replay of events for projections and reactions. Event store should typically be able to provide various logical and granular ways to separate events so that they can be read efficiently. Some systems contain billions of events, and it can be challenging to create a performant projection when replaying billions of events. This being the case, event store should provide ways to rapidly retrieve groups of events. In addition, events retrieved from these groups should maintain a global ordering, which is required by projections and reactions where temporal ordering is essential. As a source of truth, operations against the event store should exhibit ACID and transactional properties to enforce business constraints that must be immediately consistent. And finally, since event sourcing is ideal for asynchronous and eventually consistent operations, the event store should provide features that will help developers implement these operations easily. These are some common properties that an event store should support. In this video, you have seen how the different event sourcing components and patterns fit together. You began by reviewing the complete read and write flow of an event source application, starting from commands and deciders, to events and the event store, then to the projections and the read models, and finally to the reactions. Then you explored the four quadrants of how event sourcing works. These quadrants are separated into two categories. The first category is read versus write, and the second category is immediate versus eventual consistency. The write side triggers actions that change a system, whether it's internal or external. The read side constructs a read model from events that are used by queries. The immediately consistent side consists writes that are immediately visible to any subsequent reads. The eventually consistent side consists of operations triggered by write on the immediate side. You have also examined what constitutes an event store and the features it should have. In the next sets of videos, you will use all the concepts that you've learned and dive deeper into the details and figure out how to implement it in code. You will also find videos with examples of how to do it. So if you like these videos, please go check out all the other videos in this series as well. Have a good one.